Good afternoon.
Good afternoon, ma'am.
Good afternoon. Uh, so we are done up to collaboration diagram, right? Activity diagram, sorry. Now we are talking about state chart diagram. Again, this is a dynamic or behavioral diagram. If we talk about state chart diagram, it is like this: state transition diagram or state chart diagram. So it is similar to activity diagram, right? You have a start and a stop. Then, like here, they are showing you ATM system reading a ATM card. If it is invalid card, then you are ejecting the ATM card and stop. And if it is card read successfully, then it will go to reading pin. If it is invalid, again it will eject ATM card. Otherwise, it will go back to getting valid pin, right? Then you will choose, if it is valid, you will choose the operation, right? If you perform the operation, then you go to performing operation, finish operation, and your card is ejected and stop. If you want to go from performing operation to another transaction, it will again go to choose operation. And if you are canceling the operation transaction, then it will go to eject card and stop. This this is how transition diagram is drawn. For you, the transition diagram they have told you to make is state chart diagram, online examination system. So if we go for that, online examination system, I think they have made the same thing which we have seen for the activity diagram. Right here, login, start, login, validate. If it is valid, then view information. If it is view information, if it is invalid, it goes to login back. And then select the course, take exam, submit exam, view result, and log out and stop. So this is one of the ways they have shown. So in this process, they have shown start, subject choice, date choice. That means you will select the subject, your date of when you want to give the exam, select the date. If capacity is full, it will come back to date choice again. If it is available, it goes to enrolled, right? Then again, if you enrollment is cancelled, it goes to the cancel process and stop. If enrollment is present, then in progress, completed, and then stop. Or here they have also made it a log off process also. If you log off in between here, you can go, your process is in halt. That is also they have shown. So this is one way of showing, right? So the same thing which we had seen in the activity diagram. So here, this is your sequence diagram. This is your use case diagram for that, and this is activity diagram. Here, data flow diagram is also shown. They have not shown the state chart diagram because it is similar to activity diagram only. So same thing is there, which is in activity diagram you have already seen. So this is known as a fork process. Fork process in your star UML you will find this. So these are the different things you will have: initial, that is start, transition from one state to another. This is your state. Fork is from one state you are going to two other states, right? We use a rounded solid rectangular bar to represent a fork notation with incoming arrows from the parent state and outgoing arrows towards the newly created state. So yeah, these are going to two states from one state. And join means two states are joining to one. This is join state. So do you have that in your composite state? And final state is this end. So this is what like they are showing state machine diagram for an online order. So this is registered order, on unprocessed order, accepted order, pending order, fulfilled order. So start is unprocessed order, order received. That is an unprocessed order first, which is the received order. Then it will be checked for checked. The order is checked. If it is rejected, it goes to rejected order. If it is accepted, then it goes to accepted order. From the accepted order, if items not away, some items available, item not processed, so it is in pending order, right? And some items available, that means items are available and you are processing the order, you go to fulfilled order. From pending, if items are available at a later stage, it goes to fulfilled order and then stop. And rejected order also goes to stop. So something like that they have shown. This is an example of it is similar to that, but state that is activity diagram and state machine diagram and flowchart are similar, but only the difference is state machine diagram is associated with UML, flowchart is associated with programming. Basic purpose of state machine diagram is to portray various changes in state of the class and not processes or commands causing the changes. A flowchart, on the other hand, portrays a processes or commands that on execution change the state of class or an object or the of the class. Primarily used for systems emphasizing their states and transitions, often used for processes, procedures, or algorithm involving actions and decisions. This is the only difference. So it is similar to the activity diagram which we have seen. The same thing is there, like we have seen in the earlier use cases. So you can go from in tutorial point also. You have all the class diagram, object diagram, component diagram, deployment. All the diagrams are here also. You can go through them also. So this is there. This is for examination system. And another is state chart diagram for online fund transfer. Online fund transfer. So in this, first start, enter login credentials. So if login is successful, again condition should be given here. They have not given the condition. You can give the condition that if it is incorrect, you display error and retry, or you go to the incorrect OTP or incorrect pin. You go to the end, or you go to the retry option, that is enter credentials again. If it is correct, verified, check balance. You can check the balance, you can initiate transaction, you can select account, or uh, you can enter the amount for fund transfer, right? So you will initiate the transaction, select the account to whom you want to transfer the funds, enter the amount, right? And the amount, the balance is checked whether amount is available for transfer or not, right? And then from here, it should not go to it will transfer the fund if the amount is available, if the balance is available, it will transfer the fund, and the message successful transfer message is received, and then end. So this will be your basic thing. We are not talking about check and all, we are talking about online fund transfer. That is there. I don't know what they have shown here. This is was simple one, verification account operation. They have shown this one. We are talking about fund transfer here. So they are showing for online banking. What they have shown here is make it, don't make it a flowchart, make it in a start and stop should be there. So first you do not have to show this customer and bank, you only have to show that you log in. Then what happens after that, your pin is verified. If you are if it is verified successful, then this is a sequence diagram they are showing. So we should stick to that only, that this kind of a thing, but in a different way we will show that enter the login, it will verify your details. If it is not valid, it will go back to the login, otherwise it will go to stop. And if it is successful, it will uh, uh, rather than check balance first, it will you will initiate a fund transfer transaction. So for fund transfer, then you have to select the account to whom you want to transfer the funds. Then you enter the amount. Right after entering the amount, it will check the balance, whether the balance is available in the account. If it is available, then the transfer is initiated, and it goes to, after successful transfer, it goes to stop. And if it is not available, then it will say insufficient balance, cannot transfer, and stop. This is how you should make the online fund transfer in a state chart diagram, right? So this is online examination system, this is online fund transfer. Online examination system also, you will log in to a examination portal, right? You will register in the examination. Then after successful registration, you will log in. You will select a particular exam code which you want to give on a particular date, and then that if the exam is available, right, seats are available, you will pick up the exam and give the exam. Your result is displayed after the exam, and stop, finished, that is stop. This is how you can show an online examination system. So this is state chart diagram, it is similar to activity diagram only, right? Then we come to component diagram. Now what is component diagram? If we go here something, so they have shown component diagram in this. No, they have not shown component diagram. So if we go for component diagrams, so this is a deployment diagram. We are not talking about deployment diagram. We are talking about component diagram. So I'm just showing you an example of a component diagram. So component-based diagrams are essential tools in software engineering, providing a visual representation of a system's structure by showcasing its various components and their interactions. These diagrams simplify the complex system, making it easier for developers to design, understand, communicate the architecture. So, so we will show the system components, right? Your components means the modular part of your system. Like you have a problem and you divide it into sub problems. So similar kind of components you will show. So component is this kind of a structure, right? This is the symbol of the component. Like here it is showing online store, right? So define, encapsulate functionality in ensuring modularity and reusability. So this is a module. A component means a module which is containing classes, collection of classes, and all that. You also have interfaces. So to specify a set of operations that a component offers or requires servicing as a contract between the component and its environment. So interface means that you are interacting with some other component. So that will be the interface, something like this. One component interface with the other component. So they are interacting with each other through the interfaces. So that is there. right? Then relationship you have to show with a you have dependency dashed line, you have association solid line, and you have assembly connector. So assembly connector means connects a required interface of one component to a provided interface in another, something like this. This is a assembly connector. This is an assembly connector. This is a dependency. This is a solid line association relationship, right? So connects a required interface of one component to a provided interface to another, right? So then you have ports also represent specific interaction points on the boundary of a component where interfaces are provided or required. Small squares on the component boundary allow for more precise specification. So these are your ports like this. These are your ports, the connection point between two components that they are showing, right? So you can also show artifacts. So represent physical files or data that are deployed on nodes. So this is the way they have shown artifacts like this. Shopping cart.jar, order.jar, right? So like that. If you want to show, you can show. Otherwise, not necessary. You can also show nodes represent physical or virtual execution environment. Components are deployed like server or something like web server. So application server or web server. So those are your nodes, right? So you can show that. So for example, what they have shown here is a component based diagram. So here you have a order component, customer component, product component, and here you have a account component. So the online store contains order component, customer component, and product component. This component has multiple components. Online store component has multiple components inside. The order component is connected through port and interface to customer, and order is also connected to product, and they are also connected from the uh, other component will be your database component of the online store, which is having the account, which is a separate component. So this you have also this component, online store component, is connected to this. This is how they have shown. So this is one of the examples they are showing. This is how you show the component part. I know what is shown here. Component diagram is a structural diagram, right? Component. So you in the structural diagram you have class diagram, object diagram, and component diagram, which you study. And behavioral diagram you study the activity diagram, use case diagram, state chart diagram, and communication or collaboration diagram and sequence diagram. The two interaction diagram are there: sequence diagram and communication diagram. That is there. So this is how they have shown the component diagram. An example. Customer, storefront, catalog. So these are the components they are showing. Just an example, right? So in our this, if we have to draw component diagram, so this is a provided or required interface. This is a required interface. This is a required interface. This is lollipop notation. So there, this you can use again. And now a module is this, package is this, a block is this, a component is this. So you can use this component, right? You can give the attribute also in a component if you want. Otherwise, you can also have component like this. If you want this for this symbol, you can use this. Otherwise, you can use this symbol, right? So what component it is, you can write it here, right? And if you want to connect it to some other component, you can also go from here to here like this. You can connect it, right? That is there. These kinds of things they have shown. You can have dotted line also if dependency is there, or otherwise a fixed line. This is a straight line, whatever you want to draw. This is a double line which is there. We don't want that. I'm just giving you an example. Right. So this is how you will draw the components, right, and their connectivity between them. Just an example. If you want to show the port, I don't know ports are given here or not. In your star UML, ports are also there. Interfaces are there, so you can have interfaces if you want. Interfaces there. I don't know ports are there or not. I don't find them. This is fork or join, one which we have not used, so you can use a fork and join in your activity or and state chart diagram. I'm not finding port here, but in the earlier one, port is also there, so you can add ports here also. That is there. This is how you show it. In your question, in your book, the question for component diagram is component diagram for online examination system. So what all components will be there in your online examination system? So like they have drawn here, examinee access, and this component this is one component, and online examination system have exam provider information component, subject information component, exam content component, and other are in the database components are separate. This is a web server having the online examination provider information, exam provider information, subject information, exam content uh, 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 components, and those components are connected to the database components, information database for exam provider information, and result database for subject information, exam content. These are connected, and examinee access component will connect to this through port, that is through web server or some to the from the web browser to the web server to the exam provider information, subject information, this online server, and it will connect to the database like this. So this is one of the examples of a, so exam provider information has an interface connected to the database information database. So that is what they have shown like this. Right, this is one of the examples of examination. So then what is shown here, they have computerized examination system component, and there you have exam paper, student, result, teacher, which is connected to that, and this security persistent and database is also connected. So you can show in this way, but they have not used the same symbols, but you should use the component symbols as given in your book. Right. What is this now? So in this part, they are showing online examination system, and it is connected to add exam, add question, my profile components, and they are connected to the database components. This they are showing it this way. The first one was good. The first diagram, which this one we have seen, this is okay. That is how they have shown. Here they are showing the deployment diagram. We're not talking about the deployment diagram right now. So this is what component diagram is, and the other one is order processing application. So order processing system, like here they are showing new order processing component is there. You have new order component, customer system component, order queue. So mail queue is there, send mail server component, and order system. So this is one of the components they have drawn in this. What about this? In this one, they have shown shipping component, which is connected to the order processor, and order processor is connected, or interface is connected to the storefront component, and order processor is also connected to the customer service component, and the customer data, the product details will be provided to the from the storefront. So this kind of a thing they have shown in this. And in this they have shown order management system component is there, which has product component. The order management system component, the bigger component, has sub components like product, payment, customer, order, confirm, and which are connected to the database. So this way also you can show. So these are component diagrams which they have shown. The deployment diagram. Okay. So this is this was another, and the other one is online student admission system. So online student admission system. If we go for online student admission system, so here external computer is component node is there. Okay, I think this is a deployment diagram. Nodes will be a deployment diagram. What is shown here? Again, this is a deployment diagram. All deployment diagrams actually. I have it on. So in the student registration, what they are showing is student admission management component, which is having university admission, student subject course charges or fees, you can say, and that is connected to the database. This is one way of showing it, right? Another one they are showing like this. Again, this is a deployment diagram. We're not going for that. This is course registration. So here you have web-based course registration, registration file. So system, you have course registration affirmation. So student is there. Student inquires a page, gets a list of pages. So again, there are different components: registration file print, system database, post registration affirmation, registration form page component, list of courses, and inquiries page. And student user component is also there, because he will register, so there will be a student user Component inquiries page, list of courses, registration form page, course registration information system database, and registration file print. These are the components they have drawn. The student information system. Student is there, right? College is there, branch, and account. So this they have drawn it simply. Again, here they have used student registration, check pay, not. Uh, they have not drawn it completely. They are showing it in a different way. So that one is okay. This one is okay. You can show the main component is this. Inside that component, you can draw. So that can also be done if you make it bigger, right? Make a component bigger. So this will be your main component. So you can name whatever is there, and inside this you can have another component, right? So you can make another component inside these components and connect it with whatever way you want, right? That is there. So you like it is an online examination system, so this is uh, add student component will be there, then student detail component, then examine course components, exam date components, whatever different components you can draw inside this. That can be done, and then you can connect it with an interface with each other. That is how you will do it. For this state chart diagram, component diagram. So component diagram is this. They have not shown you the deployment diagram, but I am just showing you how deployment diagram is done. So for the deployment diagram, if you are asked with deployment diagram, so deployment diagram is different from uh, component diagram. How? They have not shown you the component diagram, they have shown you deployment. So deployment diagram, you have nodes. Nodes means a physical arrangement. How so component diagram was that how in a software what modules will be there, what components will be there in a software. That is how it is divided. But in a deployment diagram, now physically how your setup of the system will be there. Your like for this ATM machine, ATM system, you will have an ATM machine, right? Node. You will in the ATM machine node, you have cash dispenser, display, a network interface will be there in the ATM machine, which is connected to the bank server through the network. You will have cash deposit chest, you have keypad, you have card reader, you have print receipt. So these are the nodes which are connected to this ATM machine. And what is the processing speed they have given you, and the hard RAM and hard disk according to that. So this is how deployment diagram is shown. So if you talk about the deployment diagram, they have not discussed about the deployment diagram, but deployment diagram is also important. So if we talk about deployment diagram, so what deployment diagram is a type of structural UML diagram that shows the physical deployment of software components on hardware nodes. So let's say the mapping of software components onto physical resources of a system. So like processor, like the components you have created in the component diagram, now where those components will be on what nodes. So you have nodes, component, artifacts, similar things will be there. So if, for example, here you have device, and device is connected to what all other devices, something like that you can show. So example, here they are showing online banking, mobile banking Android services. So here you have client device, that is your Android device, where your bank app will be installed. right? So this is your mobile device, suppose, and it through web services, through internet, you will be connected to the application server of the bank, right? Where your account statement, fund transfer, component, check transfer, other services. So these services will be available. These components will be there in your application server node, right? And that is connected to the data store where your account details and everything will be there. So this kind of a thing will be there in your, right, like here for online exam registration system, what they have done is you have a login node. So instead of a login node, you can say you have a, client node, which is connecting to the online exam registration app or the server. So you can make a server node here, right? The server is having different components. You can show the components inside the server, and that is connected to the database for whatever test results or whatever information you are. So inside the examination system, you can have the components like manage profile and status, select exam, registration for exam, view result. So these will be the components inside this. Don't make it a node, rather than it should be made a component, something like that, right? So that is what how you define a deployment diagram. It's visual paradigm. So something like that. They are showing server and node and all that. So they are showing this is a node. Inside the node you have components. So this is a node symbol. You can have a database symbol also. So like here you have a web server which is connected to a database server or a browser. That means a user client, something like that. So these kinds of thing, if you show, will be your deployment diagram. They have shown in a different way, but you will show a node with the what node is that and what is it connected to. That is how you will show a deployment diagram. So that is important. You should know that. They have also not shown it correctly. So according to nodes only, you have to show that. So that is there. So in this part of the thing, if we go for node again, this is your node, I think. This block will be known as your node, and you can name the node whatever node you are giving the name, and you can have components inside this. So you can have components inside this. You can put the components here inside this, and you can connect them like whatever components are there, and this is connected to another node. This is, suppose this is a web server. This is your application server of your examination system, and this is the client machine which is connected to this application server through a web component, and then it is connected to a database component, something like that, a database node, something like that. You have to show in, in a deployment diagram. Can you understand this? Any problems in deployment diagram and component diagram? Component diagram is software part, and deployment diagram is hardware part of the same. Like here they are saying deployment diagram for online student admission system. So if deployment diagram for online student admission system is shown, So it will be something like here they have shown external computer connected to the internet to the security server, or whatever you can say, central examination server also you can connect to. And then functionality server, registration server, student server, report server, database server. So something they have shown here, this kind of a thing. Right in here they have shown admin device is there, database server is there, student management system is there, online server is there. So this is application server they are showing, and student staff device, or you can say the client device is there, which is connected to the internet, to the student management system, and or to the online server, online database. You do not have to show both here. Internet only one you are showing, and that is connected. This is connected to the interface, the database, and this, and the admin device is also connected to the database and this. So this is how you can show student admission or whatever. And in this client devices server, right, the server is connected to the web server, database server, so something like that. This is a mobile device. This is a web browser, or this is through HTTP you connect, and this is Android mobile device. So that is how you can connect to. So this is how they are showing it. You can show it in any other format: device, smartphone, scanner, admin, student, faculty, parent. Why parent are added in this, I don't know. Parent are not required, even faculty is not required for admission. So these kinds of things are there for the deployment diagram. Component and deployment diagram. Right? Any doubts in this? Any doubts in the diagrams, please? And remember, those who are for online mode, right, their practical examination will be, I think, online mode practical will be there, I think Viva based. But those who are ODL mode students, their practical will be at a center, and there will be a question paper for you, that will be at a center. Computer will be available at the center, and you have to do these questions. Like for example, MCSL 222 question paper is like this, if you see. So first is OAD, and the other one, section 2, is Web Technologies Lab. So we are talking about OAD. So there are two sections in this paper. Each section is of 1 hour duration. Attempt only that section in which you are not yet successful. So first time if you are giving the examination, then section 1, section 2, both you have to do. Like if you fail in one of the sections, then you have to attempt only that section which you are not successful, or you are not passed in. That is what it means, right? So that is what first time. So you have to give both the sections. So answer the following question, carries 20 marks, and the Viva voice is of 5 marks. So draw collaboration diagram for online banking system. So collaboration diagram is the communication diagram where you have to show communication between the messaging being passed in the system, which we have seen here, right? How you pass, this is your collaboration diagram. Customer ATM machine account. So online banking they are talking about. So you go to a website, right, and it is connected to the account information or the database, and then you can do whatever transaction you can do. So this is for ATM. You have to convert it to draw for online banking, right? That is what the question paper says. So draw collaboration diagram. Only this thing. Now you will be provided a system. There you will be having some software, either smart star UML or visual paradigm or whatever. So you have to draw on that, right? For the online mode, I think your will be Viva based. So that is a different issue. And for the theory examination, I'm just seeing what is in set 3. Set 3 is an online food delivery company provides a range of facilities to customers through its mobile app or web portal. It provides options to choose restaurant, food items, online and cash on delivery options, order status and feedback facility. Perform the following for this system. Identify classes and the associations. So what you read from this, that there is an online food delivery company. It is providing facility for online food delivery to through mobile and web portal to the customers, right? So it provides options like restaurant, food item, online payment and cash on delivery payment and order status and feedback facility. So you have to identify classes and their association, and you have to draw the class diagram for the system. So first identify the classes. So what all classes will be there? There will be customers, right? There will be uh, food items, payment, online payment, order status, feedback facility. So these classes you will identify, and then you will make the association and draw the class diagram. So this is there. This is there. How your paper is there, practical paper. But if we talk about the theory paper, so theory paper, you will have to draw the things yourself. So control F I am doing because I have to find out SOCIS, that is School of uh, Computer and Information Sciences. So under that you will go to new MCA, not the old one. So in the new MCA, your subject is object oriented analysis and design, right? This is your theory paper. In the theory paper, if you are asked to for questions on diagram, then you have to draw the diagram in the answer sheet which you will be provided. So like MCS 219 object oriented analysis and design is there. Question number 1 is compulsory. Attempt any 3 questions from the rest. So question number 1 will always be compulsory, and from 2, 3, 4, 5 you have to attempt any 3. Right. So, what is object-oriented modeling? List advantage of object-oriented modeling. Explain various stages in object-oriented modeling. What is a time-critical system? Explain how objects communicate in time-critical system. Also, explain the need of synchronization in time-critical system. What is persistent object? How is it different from transient object? Persistent means permanent. Transient means temporary. Right? So persistent object is your database, which is keeping your permanent data. What are derived attribute? Discuss the role that they play in design optimization. What is association? Explain one-to-one association with the help of a class diagram. Also explain how it is implemented. So you have to draw the class diagram and show them on the paper. So this was your first question, which is compulsory, which is of 10, 20, 25, 30, 40 marks question. 40 marks is first question is of 40 marks. Now from the second, third, fourth and fifth you have to attempt any 3. So second is what is collaboration diagram? Explain how methods are created from collaboration diagram with the help of an example. So you have to define collaboration diagram or the communication diagram, and then you are to explain with the help of an example. You can show an example. What is design optimization? Explain the task to be performed for design optimization. Third is define abstraction. Explain how abstraction results in modularity. Also explain the need of inheritance adjustment in the design process. So abstraction, this is the third question we are talking about. So that is there, right? So that is one of the things. What is DFD? Explain the advantages of using DFD, data flow diagram. Draw 0 level and 1 level DFD for online examination system. Make necessary assumptions. Again, you have to draw the DFD in the exam paper. Fourth question is what is dynamic model? Explain the use of dynamic model with the help of suitable diagram. Again, you have to draw the diagram and show. B part is what is use case diagram? Explain various components of use case diagram. That is what actors and the use cases. Draw use case diagram for online examination system. Again, you have to draw the use case diagram in this. And fifth is write short notes on the following: aggregation, integrity constraint, implementation of control, object model. So this. So the questions which are coming for drawing the diagram in the paper, you have to draw them with your hand, because though for those who have opted, and online MCA OL people who have opted for computer based examination, I don't know whether on the system the for drawing part is available or not. I have no idea. That is what I wanted to say. So remember that you should know how to draw a diagram by hand also, by system also. I have shown you if the software, through software, how you can draw. So that is important, that how you are drawing the diagram. You should know the each and every diagrams, what type of diagram it is, a structural or a behavioral diagram. First you should know that structural means static, a behavioral mean dynamic. So class diagram is a structural or static diagram. Use case is a behavioral or dynamic diagram. Sequence is a behavioral or dynamic diagram. So you should know which diagram is of which, and what is the definition of the diagram, what is a class diagram, and how you draw the class diagram. You should know what is a use case diagram. You should know the definition and how you draw it. Sequence diagram, what is the definition, how you draw it. Collaboration diagram, what is the definition, how you draw it. Activity diagram, what is the definition, how you draw it. State chart diagram, what is the definition, how you draw it. Component diagram and deployment diagram, what is the definition and how do you draw it. So these 9 diagrams, you should know the definition, you should know how to draw them. In theory also, practical also. In Viva based also, if they ask you what is a class diagram, and if I tell you to what are the classes, if I give you a situation like that, so you should know how that is done, right? Any doubts? Any doubts class up till what we have studied?
No, madam.
Right. Now, in session number 8 says we will do only this part. I'm not going further. Right. In the next class, that is tomorrow, we'll talk about the next thing. Right. So, in the session number 8, it is saying implement the following class diagram in C++ or Java. Now, what does this mean? Can anybody tell me? This university, school, faculty, this is a class diagram. You have to implement it in C++. Can you do that? Remember, we have seen in our fourth block. I'll just show you. Was that? In the fourth block, we had shown that if you have two classes, person and account, and you have one-to-one relationship, then how you just show it like this. This is a person class, this is a account class, right? So you are making a person method here, private account. So you are making this object in the person class, and accessing the account. This is how you do that, right? So this is what you have to show. Implementation means you do not have to show the full coding, but you should show how you are doing that. That is what they are asking you to do, right? Like here in the question, university and school. So you will make a class of university in C++ or Java, whatever language you know, and you will make a school class, and now you have to connect them. You can make an object of the school class inside the university class. That kind of a thing. If generalization is asked, then if generalization is there, like suppose a type of student is there, undergraduate or postgraduate, then Student will be the base class, and two child classes of that, undergraduate and postgraduate, will be created, something like that. If that is the situation, that is what implement the following class diagram in C++ or Java. So if you see here, suppose in C++, if we are talking about like this, I don't know, implementation will not be given here. And in some softwares like Star UML, you can convert some of the diagrams into code also. That is also there. Like here, they are showing you, like here, you have a circle class. So class circle private, you have the attributes, double radius, and center, right? And in public you have minus means here private, and plus means public. So public functions are get radius, get circumference, get center point, and get set radius. So that is what they have put it, right? So this is what you have to show basically. So here again, if you have shape like circle and ellipse, so you have to make a base class, and you have to make two child classes accessing the base. That is what you have to show. So you see here in Star UML also you can do that. Convert diagram to code. So in visual paradigm also, like here they are saying you have animal, and they have created this animal. So this is the class animal you have created. So I'm just saying we do not have to go to complete that, but it's just they are showing. But in examination, it is rarely asked. Examination class diagram to be represented in C++, but you should know that how it is made. You have to first make the university class with the attributes like name, address, whatever is given here, and uh, add school, remove school, these functions inside the class, and you will make another class called school with attribute name and functions like add faculty, remove faculty, and all that. So you can make all these classes, and now you will see which class to connect with which. That is how you will see that. This is what they are asking to implement in C++. That is what we are trying to do. Same here also, train journey and train. right? And here also person and bank account. So here they are showing the relationship, 0 or more to 0 or 1, right? So we'll talk about them in the next class, right? Also, that is tomorrow's class, but this is what your last section is actually about. So we'll talk about them. So until your main focus should be not on this part, implementation part, but rather than on diagram. That is the main focus, these diagrams. So all of you have attempted your assignments. Everybody has submitted the assignments, or anybody is left with the assignment submission?
I have already submitted, madam.
Already submitted. Anybody is left with the assignment submission? Everybody has submitted the assignments?
Yes, ma'am.
Okay, then no problems. If you have submitted, that is good. So any doubts, anybody? Whatever we had studied up till now? Everybody is able to understand how the diagrams are drawn, how you will attempt the questions.
Yes, ma'am.
Okay. So go through your question papers. I will suggest object-oriented analysis and design is simple to attempt, right? If you know the diagrams, if you know the content, it is simple, right? Not a very difficult subject. Only thing is, if, even if you are getting some problems, just go through the five question papers, theory question papers of your back, attempt, try to solve them, right? You will be prepared for your theory examination. Previous five question papers, just download and practice them. That's all, right? So, everybody has put their attendance in the chat box.
Yes, ma'am.
Anybody is left to put the attendance, name and enrollment number. So, we will meet in the next class now, right? And try to do further questions which are there. Anybody has any doubt, so you can ask. Otherwise, we'll end the class, today's class now. Anybody has any questions? Any questions, class? The MCA OL people should submit their assignment on the LMS portal. The MCA ODL, those who are having merit center, should submit their assignment on the link available on the merits website. Right. Your theory assignment should be handwritten, and your practical assignment can be a soft copy, a Word file. If you have codes and their screenshots, and for OAD, you will make diagrams. So you just copy the diagram and put it on your Word file. That is there, right? Those who have not done the assignments, for them. Okay, then we'll meet in the next class, that is tomorrow. I think tomorrow's class is from 8 a.m. So we'll do the other part of the questions which are available, and try to see how we'll do that, right? So I'm just ending the class. So we'll meet tomorrow then.
Thank
Thank you.
Welcome.